Alright, hello everyone and welcome. This is just a quick video to demonstrate what I've been working on recently. I've been developing a terrain generation application that makes use of Perlin noise. Essentially, Perlin noise is a type of noise that aims to create semi-pseudo-random numbers, which is used to create terrain, textures, and various other things. What I have here on the right is just a simple window with with different options that can allow you to change basically the mesh that you see in front of you. We have the resolution, which is something that I've just implemented recently and essentially changes the complexity of the terrain. So at the moment we have a resolution of 1, which means the highest resolution. But if I increase, or in other words decrease, then as you can see the mesh becomes a lot simpler, and this will be very important for LOD, or level of detail, where terrain chunks further away will have a much less vertices to of course improve performance. We also have the ability to change where the Perlin noise samples its points from in the height map. So by doing this you basically move through the terrain, which is pretty interesting. We have the octave count, which is the number of times a specific vertex is sampled using Perlin noise. So if we decrease the amount of octaves, then you'll notice that the terrain becomes a lot smoother. As again, we increase the octave count, and all the points become more sharper. Frequency is how often we sample the points, as you can see. So as we increase the frequency, you get a lot more points, and as we decrease, then the opposite happens. We also have the amplitude, which is how low or how high each point is. So when Perlin noise generates a number, it's between -1 and 1, and by simply setting this amplitude, we times that value by this amplitude. So values which are -1, for example, will be, as you increase the amplitude, it makes lower values more lower and higher values higher. We have also scale, which essentially zooms in to the height map or zooms out. We have the lacunarity and gain, which is used for when we change the octaves. So the way octaves work is that every time you do an octave, you take the frequency and amplitude and put that into Perlin noise. Lacunarity and gain indicates how much the frequency or amplitude changes per octave. So for example, let's say the frequency is 1 at octave 1, then at octave 2, with a lacunarity value of 2, then the frequency now becomes 2. We multiply the value by 2 each time, and likewise with gain with amplitude. And yeah, that's pretty much it. Some of the things I want to implement next is definitely normal mapping. Oh, sorry, not normal mapping, but normal vectors, where I can then use the normals for every vertex to calculate lighting. We also want to add UVs, which is not going to be too difficult to do, but UVs, normal vectors, and then once I can get those implemented, I can get very basic lighting, and then I can actually work on creating multiple mesh chunks so that I can actually create bigger terrain, and we'll see how that goes. So that's pretty much it, and hopefully you'll see another video update shortly.